So this section is on creating, given two functions, creating a third function, right? Because there are various ways that we can do that. So the best way to illustrate this, right, is with an example. We'll refer to this up here as on needed basis. Okay. So here we're given two functions. F of x is equal 1 over x minus 3. And g of x is equal to the square root of x. Now, f, right, is the name of this function, and g is the name of this function. I can create a new function, call it f plus g, right? This is its name, as a function of x. Okay? I create a new function called f plus g as a function of x, and that new function is found by adding f of x and g of x together. Okay? That's what this up here is telling us. Okay? Well, f of x in this case is equal to 1 over x minus 3, and g of x is equal to the square root of x. Now space is kind of limited, right? So don't write really big, right? We want to write small. And if we combine the sum of these two terms, right, to a common quotient, we have 1 plus x minus 3 times the square root of x over x minus 3. Okay. X minus 3 is a common denominator. So when I rewrite this, multiply top and bottom over here by x minus 3, I end up with that quotient. Now, what's the domain and what's the domain for this function? Okay. And so you know the domain is all the real numbers we can put in for x on the right hand side, and the value of the function is a real number. Okay. So f of x here, okay, its domain is all real numbers except for the number 3, right? X can't equal 3. And the domain of g of x, right, is all real numbers greater than or equal to 0. Right? X can't be negative because the square root of a negative number is imaginary. So that's the domain of f of x, right? X can't equal 3. And the domain of g of x, right, is x greater than or equal to 0. Well, for the first three functions that we're going to look at, the domain is the same for these first three functions we're going to look at, and it's the intersection. The domain for each of those is the intersection of the domains of f and g. So the domain for this function f plus g of x is all the values of x that are in the domain of f and in the domain of g. So you got to take the intersection of these two domains to find the domain of f plus g of x. Okay. So the domain of f plus g of x is x can't equal 3 and x has to be greater than or equal to 0. Okay. Now you guys should understand the domain of f of x and the domain of g of x, right? We covered that back in section 2.1. And so to get the domain of f plus g of x, we take the intersection of those two domains. So it's x can equal 3 and x has to be greater than or equal to 0. So let's graph the domain. So here's -1, 0, 1, 2, 3, 4, 5. X greater than or equal to 0. Put a closed circle on 0, and we shade everything to the right, correct? That's all real numbers greater than or equal to 0. But the second restriction on our domain is x can't equal 3. So here at the number 3, we got to remove the shading and put an open circle. So this is a graph of our domain now, right? We've got a closed circle at 0, open circle at 3, everything shaded in between, and then everything shaded to the right of 3. So in interval notation, how do you write that set of numbers in interval notation? Bracket, 0, comma, 3, right parentheses, right? Union, left parentheses, 3 to infinity. That is the domain in interval notation. And in the next two functions we look at, they'll have the same domain. Okay. Are there any questions on that, ladies and gentlemen? All right, the second function we can create from f of x and g of x is the function f minus g of x. And again, this is the name of the function, f minus g. Right? F minus g is a function of x. And we find its algebraic representation by subtracting g of x from f of x. So f minus g of x is equal to f of x minus g of x. Well, f of x is 1 over x minus 3. G of x is the square root of x. And then if we write that as a common quotient, right as a single quotient, we have 1 minus x minus 3 times the square root of x over x minus 3. And its domain is the same as over here. 0 to 3, union, 3 to infinity. Any questions on that? Okay. The third function we can create from f of x and g of x is fg of x. Again, fg is the name of the new function. And we find fg of x by multiplying f of x and g of x. F of x is equal to 1 over x minus 3, and g of x is equal to the square root of x. And you can write that as a single quotient. Square root of x over x minus 3. And the domain for this function is the same as in the previous two. All right, any questions on that? All right, the last function that we're going to create from f of x and g of x is the new function f over g of x. All right, again, this is the name of the function. And it's found by dividing f of x by g of x. F of x is equal to 1 over x minus 3, and g of x is equal to the square root of x. And now you should recognize this is a complex fraction, right? This is the main numerator, this is the main denominator. Keep, switch, flip, right? So we have 1 over x minus 3, right? We keep that. We switch division to multiplication, and then we flip the square root of x, which is 1 over the square root of x, right? Keep, switch, flip. And now when you multiply two fractions, you just multiply straight across. 1 times 1 is 1. And then we have x minus 3 times the square root of x. All right. Now the domain for this function begins with this, but it has one additional restriction. You got to eliminate those values of x that make g of x equal to 0, right? Because if a value of x makes g of x equal to 0, you're dividing by 0, and division by 0 is undefined, right? So, your notes up here says the function f over g is defined whenever both f and g are defined and g of x does not equal 0. So you'll note that g of 0 is equal to the square root of 0, which is equal to 0, right? So x equals 0 is not in the domain of this function right here. Right? So x equals 0 is not in the domain. So we got over here, 0 is in the domain, right? So to remove the number 0 from our domain, we replace the left bracket with the left parentheses. Okay. So we have, so maybe we'll just draw it out. Okay. So here's minus 1, 0, 1, 2, 3, 4, 5. And so before we had a closed circle on 0, open circle on 3, and then we shaded everything between 0 and 3 and to the right of 3, right? But now we got to remove that closed circle at 0 and put an open circle. Because 0 is not in the domain. X equals 0 is not in the domain. And so now when you write this in interval notation, you have left parentheses, 0, 3, right parentheses, union, left parentheses, 3, infinity. That's the domain in interval notation. Okay. You with me? All right, so if you flip over top of page 2, you have to evaluate f plus g of 5. So we found f plus g of x, right? That was the first new function we found. So by definition, this is equal to f of phi plus g of phi. Well, f of phi is equal to, right, you know how to evaluate f of phi? You just put phi in for x on the right hand side of f of x. And 1 over 5 minus 3. And then we're going to add to that g of phi. Well, g of phi is equal to the square root of phi. 5 minus 3 is 2. So this just simplifies to 1/2 plus the square root of phi. You can't go beyond that. Okay? 1/2 is a rational number. Square root of 5 is an irrational number. You can't simplify that. Okay? But that's the exact value f plus g of phi. F g of 0, by definition, is f of 0 times g of 0. F of 0 is 1 over 0 minus 3, and g of 0 is the square root of 0. 0 minus 3 is minus 3, right? So this first factor is just equal to minus 1/3. Square root of 0 is 0. So we have minus 1/3 times 0, which is 0. Anything times 0 is 0. Any questions? All right, so let's take a look at this word problem, example 2. A common air pollutant responsible for acid rain is sulfur dioxide, SO2. Emissions of SO2 from burning coal during year X are computed by f of x in the table. Okay. So x is year, right? So x can equal 1860, 1900, 1940, 1970, 2000. Okay. And f of x for each value of x is the amount of SO2 from burning coal during that year. Okay. Emissions of SO2 from burning oil are computed by g of x. So this third row gives the amount of SO2 from burning oil for each of those years. Amounts are given in millions of tons. So in 1860, right, 2.4 millions of tons of SO2 from burning coal were released. Okay. And in the year 2000, 23 million tons of SO2 were released from burning oil. Okay. That's how you read that. You're asked to evaluate F plus G of 1970 and interpret your answer. So F, now let's do it over here. So F plus G of 1970 is equal to F of 1970 plus G of 1970. Well, F of 1970, right? So X is equal to 1970. So F of 1970 is equal to 32.4. And G of 1970, right, is equal to 17.6. Which is equal to, when you add those two numbers, millions of tons of SO2, right? So what this tells us is that 50 million tons of SO2 were emitted from burning oil, excuse me, from burning coal and oil in 1970. So that's what F plus G of 1970 tells us, right? F of 1970 is the SO2 from burning coal, and G of 1970 is the SO2 from burning oil. So in 1970, there were a total of 50 million tons of SO2 emitted from burning coal and oil in 1970. Okay. Any questions on that? Okay. All right. So we covered 4 ways of combining 2 functions to create a third function. The 5th way is taking the composition of the 2 functions, f and g. But I've made a decision. We're going to get a jump on the weekend. Are there any objections? No objections? We will Monday morning start composition of functions. Okay.